This presentation will illustrate a new feature called Custom Algorithms, also known as Bring Your Own Algorithm, available in the July release of the Coleman AI Platform. The feature is mainly intended for advanced users or data scientists that might encounter a situation where none of the built-in machine learning algorithms is a best fit for their use case. The custom algorithms allows the user to package and deploy their own custom algorithmic code, apply the custom algorithm in the model training, and deploy the model for inferences. In this way, the user is essentially unconstrained in training and serving the model. To deploy the custom algorithm, follow these steps. Go to the Custom Algorithms section and click Add on the Overview page. Add the name and description of the custom algorithm. The custom algorithm code file must be compressed or zipped, checked and validated by the user before deploying it through the Coleman platform. For more information and detailed instructions on the structure of the files that are required to complete the process, go to the Instructions tab. The supported programming language for the scripts is Python 3.7. In addition to the standard Python 3.7 library, Coleman AI Platform includes pre-deployed packages that are listed in the instructions. There is a possibility to install additional Python libraries if necessary. Now browse to and select the archived zip file with the custom algorithm source code. This file containing extra trees algorithm has probably been prepared in advance. The learning process is controlled by hyperparameters. Browse to and select the hyperparameter definition file. The file must be in CSV format. Optionally, you can add the hyperparameters directly in the grid. Modify the hyperparameters definitions if needed. For more details on hyperparameters, go to the Instructions tab. Click Save and Deploy. As soon as the status turns to Ready, the custom algorithm will be available for application in the Quest modeling. Now let's see how to apply this algorithm to train a multi-class classification model on the Iris dataset. Start building the training quest as usual by applying the import data activity and the necessary prepare data activities. In our specific case, in the custom algorithm code we already have a definition of the label column called class, so the label is already known without specifying it in the quest. The edit metadata activity in this example will only move the label column in the first position in the data grid for better visibility. With the index data activity, we will convert the categorical label column to numeric values. We will apply the split data activity twice to provide a training and testing part before the training, but also a validation portion that will be connected later in the training. Apply train model with custom algorithm activity and make sure you check the field indicating that the file contains a header row. In Apply Algorithm, select Custom Algorithm. Specify the desired algorithm by name from the drop-down selection. Configure the hyperparameters as necessary and connect the algorithm as a second input into train model with custom algorithm activity. The middle input port here is optional and serves as a validation channel where you can connect a validation dataset for the custom algorithm or an auxiliary file, for example, mapping information for indexed non-numerical values. Here we will connect the validation dataset resulting from the split data activity above. The Score Custom Algorithm Model activity will score the model on the test data and the trained model input. Now save and run the quest. After running is finished, in the output of Score Model activity, there will be new columns displaying the predicted class and the columns with probabilities. To continue further to the production part of the quest and eventually deploy the model, select the activities that are included in the model construction, save the selection and click Create Production Quest. The production quest will be auto-generated from the selected activities. Save the production quest. Select the Ingest Data activity and configure the endpoint schema by excluding the label column and the redundant variables that were not a part of the training. Save and run the production quest on a sample of data to test if the predictions of the trained model are as expected. When running has finished successfully, deploy the endpoint. Specify a name and description and click Create. The endpoint represents the deployed model that is called to get predictions. As soon as it becomes active, the endpoint has been exposed and it's ready for use.